thank you for joining us for our latest installment of Current Insights from RMLD. Today, we are joined by General Foreman of Grid Assets and Communications, long title, Nick DeLeva. We wonder, what does that title mean? Well, we're going to learn. Nick's going to help us learn about himself and, more importantly, what he does for the RMLD. Nick, good afternoon. Thanks for joining us.
Good afternoon, Greg. How are you today?
Terrific. And Julie, we're going to work on this together, so it'll be a team effort. So, Nick, a little bit of background just so people get to know who you are. They already know Julie and I because it's part of the episode series. But, Nick, a little bit about your experience at RMLD, your journey to become part of the RMLD team, and then in a few minutes we'll talk about what you actually do at RMLD. But how'd you get here?
Sure, Greg. I started back in RMLD late 2009. Prior to that, I spent time at National Grid.
That's right.
Changed names a couple times, Mass Electric, New England Power. Graduated from Northeastern with an engineering degree in 93. Worked for Grid for about 15 years before I joined with RMLD. As now the title is General Foreman of Grid Assets and Communications.
So Nick, Grid Assets and Communications, a little bit of background. What does that mean? What does that do for us here at RMLD?
Yeah, so my responsibilities cover metering, our metering equipment, our metering systems, our meter reading systems, everything that goes along with that, from the install of the meter, programming, communication, troubleshooting, the whole gamut of, getting the meters installed, make sure they're working, testing them. Also oversee our electrical substations here at RMLD. Also, some of the communication devices in the field, distribution equipment in the field, testing that equipment, from distribution transformers to some of the more newer equipment like SCADA-mate switches and teleruptors and things like that.
And we'll talk more about the substations and transformers here in a few minutes.
Sure.
Let's go back to metering for a minute. So people think of meters are this little round devices stuck into a gray box on the side of their houses. What do we do with all that? I mean, what do they do, and what do we do with the data?
Yeah, so the main purpose, obviously, is for billing purposes.
Yep.
But with today's technology, we can use that data for trends, people's usage, trending, when they're using their power, when they're using the most power, certain times of the day. So we're collecting a lot of data that we can use to better operate our system.
Size the system.
Forecast. Forecasting, purchasing power, for also for load management of our transformers.
Exactly.
See the loading on our transformers, make sure they're operating efficiently, no overloads. That data can help with outages. These meters report outages also. We can.
So where the outages would be?
Yep. So this information is fed into outage management systems to help us determine where the outages are, so we can respond quickly.
So that goes back to part of the reason why the communication system that you mentioned between the meters and our RMLD headquarters, the control center in particular, that's a separate system from the electric distribution system.
Correct. It is. And it's sometimes one of the most challenging things is the communication of this equipment, metering equipment, distribution equipment, substation equipment, can be challenging on, location, where things are and how you communicate with those pieces of equipment.
We've got a lot of meters out in the service territory, Nick. About how many meters do you guys support, roughly?
Roughly about 32 to 33,000 meters.
In the network, wow.
Yeah, from residential metering to some of our all of our biggest customers, commercial metering, different applications. So it's pretty elaborate. pretty elaborate.
Big system.
Yep.
Big system. The any interesting things coming up down the road, near term relative to our metering system? I know we've got plans to do some upgrades. What's coming down the road, and more importantly, why are we doing this?
Sure. So presently now we have we're running 2 meter reading systems. Mm-hmm. Just a read-only system. AMR is what it's called. Also, that does give us some enhancements with data, hourly data. Once a day, we get reads inputted into a system once a day with hourly data. So we still have a lot of information that we can analyze. We do get power outage applications from those meters.
Yep.
And we do have an AMI system for our biggest customers presently right now. It is a little limited. Technology is changing all the time.
Quickly, yeah, it is.
It's just, this system's about 6 years old or so, 6 or 7 years old.
The more advanced AMI
system.
Yeah,
the AMI system.
And then the AMR is, 10 years old? A little more than a decade?
The AMR is somewhere, it's getting up there to be about 12, 13 years old.
So about the right time
to
apply new technology.
Yeah. So it's time to, we are presently putting together a bid specification for a full AMI deployment through the whole service territory, covering all our meters, all classifications of our meters.
Sorry, when that happens, will that be gradual, or will it kind of be all at once when it changes?
Well, it'll be scheduled out, so it'll be one project from start to finish. It might take multiple, probably a couple of years to complete and implement, but it's not going to be spread over a 5 or 10 year lifespan. It'll be more like probably a 2-year implementation process.
Quite a bit of work to put that together and actually pull it off.
Oh, absolutely. Like I said, technology is changing so quickly. We want to get a system that serves today's purposes and the future.
Take us into the early 2030s.
Yeah, absolutely.
This is the foundation, because you mentioned that's part of our billing system. So it's and it's part of our forecast system, and it's part of our load forecasting system, which goes into our power supply system. So I guess to think about it, the metering system is kind of a basic building block. It keeps track of kilowatt-hour sales, which drives purchases, staffing, equipment. Pretty significant. That's pretty fascinating. You mentioned transformers before, so kind of big picture, how do transformers kind of fit into our network? People drive down the road, they see utility poles, they see wires on the utility poles. The lower ones tend to be communications, and we tend to be we're at the very top of the pole because it's electricity. But where do transformers fit into this interesting distribution network?
Yeah, so we have a couple classifications of transformers. We have our big substation ones. So we're taking voltages at a transmission level for our system. For our system, most of it is at 115,000 volts. And we're bringing it down to 13,800 volts. That is our primary distribution voltage through our system. Also,
that's what they mean by transformation.
Correct.
115 down to 13.8.
115 down to 13.8.
Sorry,
we do have one of our substations that we transform it down a couple times from 115 to 35 kV, then from 35 kV to our distribution voltage of 13.8. So that's on the transformer end. Those are our bigger units that sit within our fenced-in areas at our substations. And the typical distribution transformer you see on your pole is from 13.8 to the typical application 120, 240 volts. That's in people's houses.
Yep.
We do have some commercial applications where it's 13.8 to
480.
480 or 208. type application, three-phase applications for our commercial customers.
So all those transformers are throughout our network, but the big ones are the ones that are at the substations that you mentioned.
That is correct. Yep.
How many substations do we have?
We have presently 3. We have one on the agenda to build. So
that'd be the 4th.
That would be the 4th.
Yeah. Otherwise known as 6th. Not to confuse ourselves with numbers.
Yeah. Even though we've gotten bigger, the number of substations have shrunk over the years, and that's basically just due to the voltage class.
And the voltage and the distribution network, et cetera.
Correct.
Yeah, very good. So those transformers, they require maintenance. Maybe think about at the substation, the big ones.
Yes.
Talk just a little bit about the maintenance required. I mean, they seem like just a simple gray box that doesn't do anything. But do they?
Yeah, they do a lot. They do a lot. So a lot of moving parts in a transformer, believe it or not. That's how typically we regulate our voltage through our distribution system is with our big substation transformers. So, one of the big things we do with our transformers is a dissolved gas analysis.
Mm-hmm.
We take oil samples from a transformer and we send them off to a lab, and they check to see if transformers have gases inside of them, might have water inside of it. And we do that every year, and we do trending on that to see.
And water and gas is not good inside of transformer.
It's not. Some gases are present when you have oil being used as insulation in a transformer.
Mm-hmm.
There are gases, and there's nothing wrong with that. It's gas ratios that you're looking at. So we send them off to a lab, and technicians look at it, and if there's any issue, they will reach out to us. They have engineers at these firms that will analyze all these results, and they'll help us if there is an issue, try to resolve it, see where it's coming from, and that type.
So these boxes that don't do much actually do a lot.
Yes.
And you can't really see what's going on inside them, but lots of moving parts. And it sounds like they require a lot of maintenance.
Yep. Yeah. We also do, electrical maintenance on the substations. So, transformer needs to come out of service, switch it around through our distribution system and do electrical testing on a transformer. So we do that depending on how old the transformer is, every 3 to 5 years. One big thing that we have to do is just a visual inspection.
Yeah.
Any oil leaks, rusting, heating, is any overheating going on? We do monitor these transformers from our control center. So,
and why would they overheat?
Loading. If you have too
higher
much,
voltages, higher loading, yeah.
Higher loading. Loading creates heat.
Mm-hmm.
So if you're exceeding the rating of the transformer, you could have some heating that goes on. If there's a problem inside the transformer, you could have some heating that goes on.
Good point.
So,
typically, load tends to be highest in the summertime. So
yes.
hence.
Yes, it does. And again, heating is not an issue if it stays within certain ranges. All our transformers have fans on them. If
The bigger ones.
Yep, yeah, the bigger ones. If there's the loads go up, the fans kick on. It's all automated at certain set points, and that's normal, very normal for a transformer.
And then the smaller transformers are the cans that people see on the poles.
Yep.
And those are the ones that we have a lot more of those. But the big ones, if there's a problem, then we've been reliable on our larger ones. But if we ever were to have a problem, that'd be rather significant, which is why we spend so much time on reliability and maintenance.
Yes.
Of the larger ones.
Yes.
3 substations, and if one goes out, well,
Call
yeah.
Nick.
Yeah.
Call Nick. Nick.
Yeah.
So kind of thinking, we talked a little bit about the advanced metering network going forward. You mentioned a little bit about new substation. Kind of talk a little about what are some of the things that are changing that are prompting us to build a new substation, for example? From a customer perspective, why would they even care about substations? But
sure.
What's driving what's driving maintenance and what's driving. Talk a little about load and what's happening.
Sure. Yeah. So electrification's happening. So electric vehicles, heat pumps, a lot of houses of converting from gas over to electric heat pumps. Yep. They are more efficient in the summertime, but it's winter load that you typically don't have. So, so with more load, you need more capacity. More capacity, you only have certain limits on the existing infrastructure we have, and if just like on a distribution network, if you have new buildings and you need to build more lines, same thing with capacity in our substations. When the capacity starts to get larger, we need more substations. We need more transformation. We need more equipment. Yeah. So that's sort of driving
that's kind of what's in
proposed substation.
Yeah, that's what's in front of us right now, right?
Yes. Yeah. You're seeing it every day. We see it. Again, like I said, I oversee the meter department. So we're seeing a lot of orders for, EVs coming in.
Yep.
More meters going out. So we're seeing it, from just the request that we're getting.
Yeah, from a customer perspective, meters, right? It's from their perspective, it's don't touch them. I mean, there should be no reason for a customer to deal with a meter, correct? A meter on the side of their house or inside of their building.
Yeah, typically not. Some people are curious. They want to go out and read their meter. They could see the reads that they're on their bill, their meter numbers on their bill, and they can go out and they can take a look at it and see what's on there. We get a couple calls a year. Why is my meter always flashing? But it's got a certain cycle it goes through. And we set them all up the same. So it scrolls through the customer's reads that they see on their bill, and then it does what we call a segment check. It'll show all 8s on the meter, and it's basically checking
Display
to see if all the LEDs are working on the meter. Yeah. So, but we do get a couple calls a year, people asking, why is my meter scrolling like that? So, but that's why. And that's why it, you'll see your read on there, and then the display will go blank, and then you'll see what we call a segment check, all 8s, and then it'll go blank, and it goes back to your meter read. So,
Julie, that kind of brings up a good question relative to communications, right? So just in a nutshell, somebody has questions. Where do they go to find answers?
Our website, and we have everything on our website, but also we have a dedicated customer service team that people can call. But typically the answers will be on our website.
Yeah, good. Nick, on the metering system, the other thing that people hear about is time of use, right? And that's something that we haven't rolled out completely because the network's not quite ready for it. But when we do, what will it make a big difference from a customer perspective, from a metering perspective, I should say, not from a customer perspective, because that's going to depend upon what time of use rate they go under. But
yeah, as when we go out with this, proposal for bids, we're going to want meters. We're going to want to purchase meters that have several possibilities of time of use schedule.
Yeah, exactly.
So, with the electrification and, what we want to do and how we want to monitor the system, we might want multiple schedules in a meter that make it attractive for customers to, manage their electricity use more efficiently. So, we're going to be looking for, meters that have multiple schedules that can be done. As far as for us, it shouldn't be much of a difference. We'll create these schedules. The meter's got to be programmed anyway, so
more data.
It's just more data. So, but as far as the installation and the meters they'll look all the same. They get changed out the same way, so not that much different for us.
So Nick, just kind of in a moment here, I want to ask, what can customers do to make it easier for us on the metering side or transformation side? I'm gonna summarize the substation transformers kind of behind the scenes, right? Mm-hmm. You and your team do a lot of work. There's maintenance, ongoing monitoring. There's a lot of work that goes to make sure that and they're critical parts of our system. But that's kind of behind the scenes. Mm-hmm. It sounds like the only thing the customers tend to see are the meters, and besides the poles and the lines, but the meters. But from either a metering perspective or transformer perspective, any things that you want the customers to do or not do, things that would be helpful for us in terms of maintaining our network. What comes to mind? Anything, maybe keep, shrubs and vines away from the meters. I mean, just kind of thinking out of the box. What things would be helpful for us?
Yeah, that's probably one of the biggest things that we deal with. Nobody wants to see the meter. You hide it behind a bush type of thing. But when there's a problem, we have to get at it. So. It's easier for a customer to keep it clear for us. So when a problem does arise, we're not, cutting people's bushes down and that type of thing.
Which we don't want to do.
Yeah, which we don't want to do. Yeah. Biggest thing is just keep an eye on the stuff. If you see a problem or, something's rusting out or your wire is low coming to your house or something looks frayed, just give us a call.
Yeah.
We're there 24/7, 365. Just give us a call, and we'll come out, take a look at it, and we'll see
what the issue is and figure out what the solution is.
Yeah, see what the solution is. See what needs to be done, and if it's something that needs to be addressed right away, or can wait till the next day or next week. Put in a normal schedule for it to be repaired or re-engineered if it has to be. But just, let us know. We're here for our customers. And like Julie said, customer service, email,
website.
They go over the website. Everything goes to customer service. They check it every day.
Yeah.
And they get it. They'll get it to the right people.
Yeah. We've got a good team.
Yeah.
So today we have a pretty good idea of what's coming down the road, what expectations of customers. And you started talking earlier about the transformation. But kind of thinking down the road, our load's going to increase. Some of our forecasts have the loads doubling by 2050, driven by electrification, driven by the 2021 climate bill, and that drive toward electrification of transportation, hence EVs, and electrification of buildings, hence air source heat pumps replacing at the right time, replacing oil or natural gas fired heat, which have a big impact in the wintertime, but not a big impact in the summertime from our perspective.
Yep.
But just kind of thinking about, the need for bigger transformers, more transformers. You mentioned we're building another substation, right? And that's driven by load growth. Thoughts about metering or, more importantly, transformation, any thoughts about what the future is going to bring? Just where we get, big picture stuff. Number of transformers, size of transformers, substations, anything stands out. I mean, I think we have a pretty clear path, but, from Joe Customer, he's not going to see our new substations. Is he going to see a big difference? Maybe not. I don't know. What do you think?
Yeah, I don't think there's going to be a huge difference. We are, with more EVs, there's going to be more transformers on poles. The poles are only rated for so much loading, so
being weight.
So you don't want to go too big. You don't want these big monstrosities at the top of the poles. So it probably will end up being more transformers on different poles.
Different poles. Yeah.
And it all depends on how fast electrification comes. It will kind of dictate, when we get those transformers. So that will probably be the biggest thing that customers might see us out there doing more work, upgrading equipment, distribution equipment. Usually when we're in our substations, behind fenced areas, and
Purposely.
You don't, correct.
Right.
You don't really
Exactly
see what we're doing.
Yeah.
Where we might be, over years upgrading equipment in those substations, which might not, except for our local neighbors near the substations,
Yeah.
A lot of people won't see.
Yeah,
but
there's a lot of work behind the scenes that
there is.
Your team in particular, right? The meter team visits customers all the time with your new services, et cetera.
Yep.
But you've got the people are cross trained, but when they're out doing substation work and transformer work, that's pretty much, particularly in the larger ones, that's pretty much behind the scenes on purpose. Right?
Yes, exactly.
Yeah,
exactly.
But still critical, as we mentioned before.
That's right.
Julie, I'm going to, I think in a moment here we're going to do our question of the day. Nick, thanks so much. Very, very helpful.
You're welcome.
You're welcome, Nick. All right, our question of the day. This was actually an anonymous one, so we can't give anyone a shout out, but if you're listening, you know who you are, so thank you for the question. So, what can I do to lower my electricity bill without sacrificing comfort or convenience? It's $1 million question, right?
It's a multi-million-dollar question. So, Mr. Customer, Mrs. Customer, what can I do to reduce the electricity bill without sacrificing comfort or convenience? That's an interesting question because at the end of the day, your electricity bill, your monthly bill, is driven by two factors. One is the rate in your rate category, and if it's a residential, we have a regular residential rate, and then we have what's called an A2 rate, which is a residential time of use rate. And so that times the kilowatt hours, which is the amount of energy that you use over the course of the month, is going to define what the magnitude of that bill is. So rates are defined as part of a process that we go through, a lot of analysis we do on an annual basis. Because we are a public power entity, we are a not-for-profit, we have to be consistent and fair to all of our ratepayers, and part of that consistency is the consistency of the rates. Your base rate doesn't change, but there's two key components that on a residential bill. One is tied to energy, which we call fuel. We adjust that because our power supply is a straight pass-through. And then the other one is PPCT. In order to, so the rates, you don't have much control over the rates. We don't have a lot of control over the rates. It's tied to wholesale costs primarily. That's 70% of the bill. So the only way to really reduce your bill is to reduce your usage. And so now the question is, how do you do it without sacrificing comfort or convenience? And that's right. At the end of the day, it's called changing behaviors and patterns of behaviors. The very basic element is if you're not using an electrical device, turn it off. Right? Unplug chargers out of power strips. Turn the lights off when you leave the room. That used to be a great one because lights used to be incandescent. And incandescent lamps use a lot more electricity than LEDs do. Basically turn things off when you're not using them is probably the biggest single item, and then try and make adjustments in terms of if you're on a time of use rate, when you use. So another element would be to look at time of use rates. And as Julie mentioned, we have a pretty extensive time of use description on our website, so you can take a look at that. There's actually a little tool that allows you to put your load in and give you a sense of what your bill might look like, and then if you call in, we can also run special analysis. Great question, so thank you very much.
There's some other things. So we offer a free home electrical energy assessment or an energy audit. So you can have someone come out to your home, and they will give you, minor things to major things, maybe replacing your windows. That's a big thing, a costly thing, but there are also easy measures you can take, like air sealing or, stopping some, like the drafts around your windows and doors. And also there are measures you can take that won't sacrifice comfort or convenience, like washing your clothes with cold water, things like that. So that requires a lot of energy. So we do have energy efficiency tips on our website.
Our website has lots of them. Yeah. Well, thank you for that question, Mr. and Mrs. Customer. And we wanted to wrap up this episode of Current Insights from RMLD. I'm your host, Greg Phipps, with Julie, and the two of us are hosting. And Nick, thanks for being here with us today.
Thank you for having me.